What's up, guys? Today we're gonna take a look at the part 2 of TypeScript. If you did miss the other episode, there was the part 1. Please, before watching this episode, I think it would be super helpful to look into the part 1. The part 1 goes through the fundamentals of TypeScript, so not really connecting things to Lens Studio, but more like talking through the points of how TypeScript works and the comparison of someone like me coming from a C# background in Unity, and generally like TypeScript, like you learn everything from scratch. That's the part 1. In this part 2, we are going to start to connect dots with the Lens Studio API, and specifically, of course, focusing on spectacles. So we're still not going to open Lens Studio for this tutorial. We're going to actually open Lens Studio for the next tutorial, which is an overview of an existing example called Essential, which I would highly recommend to look it up. And example is a good example because like it takes all of the foundation that we go through all of these part 1 and part 2 and just put them into practice, like what's possible on Lens Studio and showing what's possible, of course, on spectacles. So I hope this is going to be really helpful for you to start connecting the dots between general vanilla TypeScript and the Lens Studio API environments and generally spectacles environment. So this is going to be a 6-part, so 6-section tutorial. Put together a lot of good materials for you, and this repo that I will be showing now, and I will give an actual overview of how everything works, is going also to be, of course, down in the description below in the video, so you can access it to any time and check it out. Without further ado, let's get into this project. The project, as I mentioned, has 6 sections. We are going to go through basics, components, events, scene objects, hand tracking, and async programming, and best practices. This is a collection of a lot of very common patterns that you will find when you code in Lens Studio. So for who's this tutorial is for those people that went through the part 1 and also are interested in understanding, or maybe they know already TypeScript very well, and they want to see how that is implied and how that is implemented in the environment of Lens Studio. So we will see very common pattern that you might actually look through and probably implement so much when you will be working with spectacles and Lens Studio. Here, for example, we see in the first part, which is the API nodes, see this example components, which is the very simple class that has an example. It starts with a component decorator, and it just says export this class example component and extend the base script components. Once again, coming from a Unity background, I will start to a lot of comparison. I believe that most of the people that watch this video also have a very similar background, so that's probably most helpful piece of information. You will see that this comes from base script component. Basically, in Unity, it's the same thing like behavior. And so here we see how very similar is to evoke something on awake. So on awake, you're doing something like this. Thing that I wanted to mention that is part of our documentation. If you go on this page particularly, or documentation, you will find a full section that is called Lens Studio for Unity developers. It's going to give a lot of snippets and a lot of code for you to understand how things work, but also something that is very valuable to me is understanding how lifecycle events work. So there you go. This is really what I wanted to show. We have a wake event, we have a start event, we have update event, and then we have the physics update, animation update, and then we also have the late update event. So very similar to what you could find in Unity. Then we have on enable, we have on disable, and we have on destroy. So really, this is all you need to know in terms of the life cycle of events. We will go through, and also we will see how to bind the start event to awake, which is might be something a little bit different from what you've been seeing before. But beside doing that step, I think you're going to be fine. Here, it's really what I was showing you before in more of a diagrammatic way. So this is all the things that you will need to remember. So we have the life cycle events, and then we have additional events that probably of the other ones that you see here are going to be very helpful for you in the inspector of Lens Studio, but really when you're doing stuff on spectacles and you're building your application. We have like ways to get components. You know that in Unity, when you get component, you kind of do it this way. You do it a little bit differently, but here there is some example on how you are getting the components. You see that it's referencing always the scene object first, and this is something necessary. So if you don't know why this is happening, just go back on part 1 and just look at TypeScript works generally, meaning that you probably had a reference in your script which is your scene object. So here, if you want to do something like this, meaning that you're just having like a specific reference here of this, or the scene object itself that is like holding the script. It's also something that I know that might not know is like global namespace reference. So if you go again in the documentation namespace, which is built in here, and you will see that you have a lot of global here, that like a lot of global references. For example, one of the most famous one is like a scene. There is also this create scene object, which belongs to global scene. So you see how to do this thing here. It's helpful to know that there is this sort of global namespace reference that it allows you to access certain specific things. Probably the one that you will use the most, especially at the beginning, this accessing to the scene. Another thing that you might need to know when you get into environment is the fact that you are going to import a lot of packages. Studio is working under the hood very similarly to Unity in terms of packages. You will import packages from the asset library, and then this is the way that you reference those packages. For example, here we have just a little bit of a micro example where we import LSTween, which is an animation package, and then you here import Async from that package. So this is an example also of how using a package within your scene. And here, for example, we're just animating with a specific way our scale of our object. Another thing you might meet in your journey to Lens Studio is loading examples. So this is the way that you load things. You can load through using this remote service model. You'll see a lot of time this kind of constant here that requires you to declare a module and have this model within your scene. If you're a little bit confused of what this is, documentation, you can go on spectacles, and then you can go on APIs, and you can go on internet access, and you will understand what it means to with these models. And I think that was a little bit out of date, but most likely you will meet this internet model because this is the way to do things when you are interfacing with external API. And then if you are interfacing with internal API, meaning that these are not really internal API, but let's say allowed API, there is this concept in Lens Studio that when you're interfacing with external APIs and you are in the same moment you are accessing very sensitive data like microphone and camera, your lens will be flagged as experimental. If you go through this new initiative, which is called Remote Service Gateway, you will be given a token, and that token will allow you to just publish your lens without being flagged as experimental. It's really just to allow everyone to publish lenses safely. And if you are connecting to the internet and you're trying to interface with the internet on your lenses, these are the places that you need to look into. Then let's go ahead. We see the transform patterns. Transform patterns are probably the most familiar thing that remains like Unity. We have world position, of course, and get world rotation, world scale. And in Unity, you would do something like transform.local. And here is get world and get local. It's like a little bit different. Instead, in Unity, probably was something like this from my memories. This is very similar. Probably one of the most similar pattern, and these are very much the basics of understanding how to just write scripts in the Lens Studio environment. Types, not really a lot of things different here, beside the fact that you have these let prefix which come from the TypeScript to do things, and then here you actually down the type of your variable, which is something that of course make things a lot better comparing to JavaScript. I know that a lot of people are into JavaScript, but I highly recommend to use TypeScript if eventually you with big projects and you want to debug. I think this is really the way to do it for develop on Spectacles or Lens Studio generally. Is probably a lot more reliable and easier to debug if your project becomes bigger. See here we have vector3, we have boolean. In Unity this is called bool. Go through the TypeScript part 1 tutorial if something is a little bit unclear. Everything will make a lot of sense. The primitive types that you might find, you have instead of integer and strings, nothing really changes from the previous tutorial where we saw how things work in TypeScript. We actually have the type that is called number, which include integer and includes float. We have string, boolean, null, of course, and all the rest. So this is very straightforward, a little bit repetitive. Might see often, of course, scene object, components, to the general way to call components. And then we have plenty of example on how to access components. And this probably will be more part of the next tutorial because there is no point of accessing component if you cannot test it in Lens Studio. So I'm probably going to just give an overview there. Another thing that you might think that is different from Unity is actually something when you reference your prefab. I think is missing in here, but something also that will come up very often. Oh, actually, there you go. It was here. I didn't see it. This is the way you reference the prefab from your scene. So once again, very, very similar to Unity. really different here. And this is a whole example of a class where something that you could find yourself writing. Like you see that you have an input, you have the name of your variable, you have the type of the variable, you have the value that you assign. And do not forget to do this. This works also without this, and that's the thing. The TypeScript in TypeScript has this thing that kind of the type, but it's always suggested that you declare it so there is a lot more clarity and you encapsulate right away. Thing that you will find, with maybe anticipating something that you might find later, is this allow undefined, which means that you don't need to set up a value and it won't throw you an error. Don't use this often because I actually don't want the developer to not see errors. And another thing that I use pretty often instead is hints. So it's the Unity tooltip hint. So you're just gonna see this when you hover on the inspector on the variable. So that's something you might probably use a lot of time. That we do some stuff in awake here. We just like these, it's how you call a function. See this, and then it goes to an handle optional object. Then you have a void. In Unity, this would be something like void, do this, something. And instead, we have something like this here. So we set if the function is private or public, we do here also. So because this would be something like that. And then we have the name, and then we actually specify the type in here. So it's kind of the inverse. The rest, as long as you understand that you need to use this when you are referencing things that are part of your class. So for example, here it says this vector to string, meaning that we have vector to string here. If you are referencing something that is in the inspector here as a variable at the very top of the class, you also are going to use this because you're referencing things that are inside of your class, and so on. And the rest is really just very similar to Unity. Then let's go to some function. I talk too much about functions because I think we saw many examples in variable types. All you need to know is that really you can do this basic function. However, something you might see very often are arrow functions. Arrow functions differ from normal function because you of course cannot call these arrow function before you declare them. So if you want to make a C# comparison, this is more like a lambda or anonymous function where you need to assign this function before to use it. Here is a very little example. Traditional function, this is before you create the function, which is like long function that you can call it anytime. Instead, here you declare it first, so you declare it with a constant here, and then of course you can use it in this way. So this is something that you will probably find so many times in TypeScript, and it's something that you might know, especially when you see this method way to hold the function with the arrow. That's why they're called arrow function. All right, let's go into object classes. So this is one very structural piece of information. You might see a lot of objects that are like this. You might see a lot of interfaces that are like this, and this kind of remains exactly the same of what we said in TypeScript part 1. So I'm not going to go through this one. Class 3D, you have a class which is not inheriting from the base script because has very common and very reusable that don't really depend from the Lens Studio API. And this is also something that you would do very often in Unity, so no surprise to see. Let's see if there is some more additional example here. Once again, private, public, these are basics that remains across the language, and these are all very well explained into we see in the TypeScript part 1. Getter and setter, same thing. Inheritance studio. So once again, this is very common for part 1. Nothing is really changing. I'm not going to overwhelm you with more additional repetitive information if things stays exactly the same. Like we see here, what is changing is mostly what we do within the functions or like within these classes. I know in Lens Studio you might deal so much with things like moving stuff, rotating things, and things like that. This is something that you constantly do, and this is a way to do it. So that looking into the transform class, I feel like it's going to be very helpful. Okay, talking about arrays collection, this is something that I'm not gonna. This is actually something interesting here. I have to actually go with this because sometimes you might find this, especially the shift, and feel like this would work with arrays when we are dealing with hand tracking. So we're going through all of the joins and we are shifting and unshifting. When we want to just specifically go and bring like from one place to the other one. For example, there is an array that has the finger index tip for left hand and right hand, and you shift between the two. So this is something that I've seen around, so I just wanted to miss. And you might find very often in Lens Studio arrays, but this is really typical of game engines, is object pooling. So that means that you are instantiating a series of objects, and then because you don't want to get, let's say, infinite, create a sort of pool, and this pool has a limited amount of object that you keep in the scene, and you just use them, and you keep like recycling based on what you have to do. So this is object pooling, is also included in this example. You might see some more depth, this example in depth, but the long short, you are basically seeing only 10 objects of 1,000 that you actually are working with, but you see them like for two, they turns in being visible or being interactable, or like your game for what you have to do. And this could be, for example, a scene where you want to have objects everywhere in your game, and that you want to work with so many different objects in front of you, but you just want to have those ones that are the closest to you to be enabled and active. You don't want those one behind, so you're just like pooling based on distance, for example. That's a very common pattern that I've seen around. Saw in the first section, we went through the API notes that when we see something here, we have this component decorator. What is the component decorator for? Well, that's really essential for Lens Studio to show up in your inspector. If you don't add the component decorator, that's not going to be usable in Lens Studio. So you cannot drag and drop the script that you're using in Lens Studio. So very fundamental. Just remember that you need it. If you just have like a pattern of your classes that you're always keeping there, you're not going to run into this issue ever. But you know that without that one, your class won't show up into the inspector. There are also ways to create widgets, which in the world of Unity maybe is just simply like a editor UI in your inspector. So like you're playing with the editor and showing what are things like drop downs or slides, where in the inspector you can just like directly the handle of the slider and things like that. Those are called widget, and there are a lot of them available for you. Those are probably the most used. Combo box widget, so drop down, the text area widget, so you have a text where you can just like write in it, and then the slider. So I would say these are one of the most used. Briefly about components, not different from Unity, but one that I want to bring up is this one here. So sometimes for some reason you will find yourself to do this. So you will actually find the script name you will find actually your component using this thing called get type name. Once again, this will be all example provided to you, and also you will have an example of all of these stuff working in Lens Studio as well. So this is mostly like a way on how to think when you're working in Lens Studio with TypeScript. So this is something you will see very often. Then for that, you won't see actually very often. You will see in some cases where you have some custom component that you need to retrieve. Then you will see most commonly stuff like this. So you will see get scene object, get transform, which are the built-in components. And then if you have your custom components, probably these are the most common patterns that you will see. You will see get component, and then between this is like a string. So like you write it down like this. In Unity, it's completely different. You don't do this. You actually dot, then you search it in the list of the available component. Here instead, you need to know a little better the API, how it works. And that's why I'm providing you so many examples for you to start with. So you will be able to reference them and build up all of what you want to build. So see here, for example, component text and so on. This is another thing that you will see very often, is actually binding a function. This is part of this chapter, but I just saw it, so we're just going to talk about it for a second. Binding the function is something that might not be too familiar for you as a C# developer, or maybe as a TypeScript person entering Lens Studio. This is something very common, and let me give you another example. Actually, the essential project which I will show in the episode. So I feel like this is a good way to understand what's going on. Notice that creating actually on Awake, I'm setting up start and update. This is something that you will probably write so many times because it's just a normal life cycle that you need to go through things. And this requires you to bind stuff like this. This is a different way to do it than what you see here. Here we are declaring an event first and then we are binding, and instead we can also just do directly this create event and then bind this, because we are in the phase of base script component. So we say that we do this directly. We don't need to reference and bind. It's the same thing. You just bind directly without just before declare this create. So this is two ways to do it: this dot create event and then your event and then bind. And then instead, if you want to do it more the old way, you just like declare it and this create event, then you bind it to something else. In this case, what we are doing, we are just creating a delay callback event, which is almost like asynchronous, that is going to be going for 5 and then clean up. So calling the cleanup after 5 seconds. So that's something that might be very helpful and something that I really found often referencing. Also, this is something I a lot of time as camera. So you create component with your string, but also you are saying as and then the component here. In this, it's a way to reference existing scene objects and then creating a component on that scene object. So for example, here you say camera is going to be this scene object, create component, and then you give the type of the component, and then you say as camera. Same thing goes for text, same exact pattern. Text, this scene object, create component, text as text. So this is something that might really happen so many times, and you're too familiar with this. I anticipated a little bit this before, and now we're gonna go more into the details. This is a lot of example for it's an example for binding things. This is we saw before. We just did an event, and then we create the event, and then we bind it. There's also a cooler way to do this, which I showed before, which is especially for create and start. You see here what we use this kind of arrow here, and this is just a faster way to do it. I recommend to do something like this. With this arrow, you're just gonna go here, just open the parentheses and just doing stuff inside of the parentheses. So once again, 2 ways to do it. This is one, and this is the other one. And we have the arrow here, so same stuff. Delay callback event, and you want to do something similar but more of a coroutine-like pattern, which is something very, very common in Unity. You could do something like this, which is kind of the same thing. You are like going recursively, delay callback, and you're just binding the same method. So you're just recursively thing. So here it's like a delay call that turns into a coroutine. Here for you, if you ever want to use something like that, which is something like a pattern, which is once again super common in Unity. Before, you will probably looking at events a lot. You are subscribing things to or interaction. So in the case, for example, you have a series of triggers which you subscribe and say, wait, when there is this trigger primary event, just do this, just do that. So once again, I want to be repetitive a little bit because we're learning stuff. And this is the way you create events, and you just do stuff inside of the events. If you're wondering again, where are those events at? You might find it all in our documentation. So here, for example, is like a little example of how to add something on pinch down on the left end. And like you see, the structure remains exactly the same. The only difference is that in this case, you're not actually binding. You can just do add. So we will see. We will go into the details of the interaction kit. But for now, just remember this. And then remember just a little bit how this change when you go into doing things like on pinch down, add. So we will do this very soon. But so you get a sense of how things are. Scene objects. See, these are probably some of the most common operation that you do. So probably very that we're gonna go through now about what in Unity you would call game object, and here you call it scene object. And the way you do things remains very similar. Use things like get transform instead of transform. So this would be Unity. This is Lens Studio. Local position. This would be Unity. Instead, we are here and set get local position. Local rotation, same thing. Local scale, and we do all of this good stuff. This really transform operation, creating scene object. What I care about honestly here is just the transform operation. I think after you know this, you can do most of the stuff already. You don't need much. And then this is a very common pattern from Unity. So enable. So you got a component, you can enable it false, enable true. Guiding the system, you can transform the object in this way. So once again, get local position, get local rotation, get world position, get world scale. Long story short, you need to put a get of what you were in front of what you before you didn't have to put it. Like instead, before you have local and you add rotation. Now just understand that you have you need to just put get world or get local. So that's something that you might we can here. We also have direction vectors, which is probably something you will use a lot, and all of these very common pattern from rotation. And we will see to all of these solvers behavior in the next video, and all of those examples will be ready for you. We get probably into the most important part of this tutorial, which is understanding the SIK. So let's also go through a little bit the documentation. One probably important part of starting to do with spectacles is understanding how the interaction system works, and how to subscribe to event for when you perform certain gestures, or how to access joins of your hands, or how to access other things you want to recognize, like poses and things like that. So let's go through a little bit the overview of how the interaction system work. Just remember, in Lens Studio, in Spectacles environment, you also have access to the mobile controller, which is also a good add-on. But here, the very hopefully very familiar interaction system, hand tracking, hand visualization, and so on. So we get into the interaction system. The interaction system is composed mostly from two actors, two entities, which are interactors that manage the interaction. So those are things that actively interact on interactables, and the interactables that receive the events, so you can interact with. And if you are a Unity developer, you might know all of these things already. If you're not, I hope that this kind of let you understand what you're seeing when you open Lens Studio or you do things like that. This is a little bit of an example. You always have JavaScript and TypeScript. I prefer to go to TypeScript here because this is the focus on this tutorial. So you see what happens here. We bind it. So we went through this before. You need to bind stuff, and you need to bind the lifecycle events. And then here we just get the component interactable with get type name, which I also brought up before. So I told you that this could be something that you do very often. We don't have semicolon here. This is if you put semicolon, this is still working. So just so you have the reference, we describe this interactable that we declare, and we see get interactable by scene object, this scene object. Then here we see we define callback logic for the interactable event. So in this trigger start callback is something that in Unity you might see as onSelected entered. So let's actually go see those things. We are here in the class interactable. So this is you on the API. So this is the way to find it. You just go on the you look for class interactable. If you wonder where is the API, you can always access with the API reference. And then you can go here, and then you can go in Lens scripting. The class has all of the things we were talking about. So if you're confused about what are the events that are actually happening for interaction, you find them all here. So on hover event, drag end, async, on interactor over enter, interactor trigger start, which is the one that we were seeing before, interactor trigger enter, interactor hover, on over, and so on and so on. So these are stuff that you need to interact and use events. And we have a lot of these examples for you already, so you don't need to go crazy and just like go through all these API, but you will a lot of this. So that's why I'm showing you where to find it. If you have any another very common one is the manipulation. So interactable manipulation, you're gonna see how to use it. So on rotation and on manipulation start and so on. So these are all events that also we have in the essential example. And so make sure that you just pass through this. Now that you know where to find events, you're pretty much covered. But these are other patterns that you might see very often. So there is a hand provider, which is called and which is a type of end input data. Then you have two kind of hands, of course, left hand and right hand, which is the tracked hand type. And then whenever you have the hand provider, you can get your hand left or get the hand right. Very, very common. Start, and so you're updating the end tracking here. This is what you to do, but just to tell you how things work, and you start to use this very interesting conditional for stuff. So for example, now this is actually what I wanted to show. If you go in this page, if you go to the interface base hand, you will have a lot of very interesting stuff, like for hand visuals, get palm center, get facing camera angle. So am I facing with my hand like the camera, and what is the angle, right? So this is actually very, very interesting. We do stuff like, for example, a custom hand menu, and you understand when to enable that hand menu. get the center of your hand, get the direction. So where the pinch is like transferring to. So this is actually super important. Now you're pressing on a button, you're making your own custom soft button controller. You want to understand the direction of the interactor. That's something you want to look into. Is facing camera is kind of like a cat facing angle, but it Boolean. So he did basically the job for you. There is a fixed number. I'm not sure exactly what it is, but it just tells you, is it facing the number or is not? Is pinching, is tapping, and you can add all of these good stuff on pinch down, on pinch up, on pinch cancel, and then you can get, of course, all of the key points of the hands. You can also get this stuff without scripting. You can also get this stuff in Lens Studio when you on the scene hierarchy in the hand visual component, and then you can find them all there. So this is something that you right away. So yeah, hope that you find helpful these sections in our API. This is kind of something you don't know right away. So this is a shortcut for you and just looking for those information. Very interesting. It's also very easy to access the mobile controller. You might not know that actually SIK has access to your phone, because when you install, when you put spectacles, you have basically a mobile connected to it, and you can use the touchpad of the mobile application to build your lenses, which is super cool, and you can do so many things with it. I saw very wild built by developers like, R and things like that. Hand visualization, also this is very important because you can literally get where you want to attach objects. So this is a very simple example of attaching a game object to our index number 3. So we're going to see in our documentation what's the index tree for, and we're just going to attach it there. And you probably see it also in your Lens Studio scene. So super helpful things that you keep there, and just like make sure that because those things that you probably will really look through a lot. These are other examples. Here's the visualization. So these are all of the join names that you can find. Here I'm sphere for each join. So my custom, my visualization. And the patterns remain. Look at this. So once again, arrow here, and we just do stuff inside of the parentheses. This is something you saw multiple times in this tutorial. I hope that it's been absorbed. And if not, we have all of these examples for you. An routine done with a delay callback event. But here are some async patterns that you will probably meet in Lens Studio. This is simple delay. Number one, the delay. So let delay event, and then this is going to be a delay callback event. We are creating this sort of events, and then once we did, we bind it, and then we do something with that. So this is very standard traditional pattern, and you can look through this and just over and over. This kind of just play on the same understanding. Promise. This example show you how to do promises like things. So here you see that on awake we launch resource async. Resource async has this pattern to say on complete, do something, and execute this void. And here we can't here. So this is the same pattern we see across, and then we are binding result, which is going to say status success and data resource content. And if we are going on success, we are completing this. So this is something that you might find, and explains you how to set up a promise. A pattern that you might find is the lerping animation. I highly recommend to look into this asset library package called LSTwin that takes care of all the stuff for you. You're just going to implement basically a very simple function that is included in that package. LSTwin really made for easy animations, Lens Studio. But if you want to go to the source of things, look at this. We have a position, and then we lerp from position A to position B with a specific velocity and time relationship. So once again, this is very common in Unity, and we also doing this often in Lens Studio. And you see this so animate position, very common. Animate color, same thing, and so on. And so this is something you might find a lot, and there is a lot more examples for you here to look into. With 3 more points. The first one is about code organization. The second one is about performance, and the third one is about debugging. In terms of code organization, I would say the most common structure I've seen in projects, and the one that I personally recommend, is something like this. So having very much under the asset folder, everything like this. So it can sound basics, but you won't believe how many projects I keep receiving to support external, and actually this is not what I see. I see actually a lot of files in the same level of directory structure. It's super for everyone to look into these things in this way. really, like, if you work in teams, I really don't understand how you guys can manage that. That's crazy to me. So I recommend to keep very much like a very good in your projects, and also possibly never unpackage these packages that you have in Lens Studio. So you will see when we will get into the studio how things look like. Hopefully you already looked into it a little bit, but please things inside of directories, and I think more like this kind of directory structure is very not just for people, but also for the AI that will help you through your project. I throw a script of 1,000 lines to Cursor, and I ask to add a feature. That's going to be very difficult for the AI to wrap the head and just understand what to do. But if I have a very good structure of directories, and I have a very specific name for each script that describes exactly what the script function is, that means that I will understand perfectly what to do at the time. So it's a lot easier, not just because the AI is made of human patterns, right? So we are not that different at that point. So it's really, really helpful to have very organized project. So don't take this part lightly. You think, yeah, that's okay. Please keep track of your stuff. Don't do script. Also take of how you name the scripts and what's the relation between them, implement interfaces, implement abstract classes, and so on. We will see all of this stuff in more examples in the future. I don't know if you're familiar yet with this repository, but we weekly update this repo, and there are so many different examples for you to look into. And all these contain hopefully all of the best practice I'm talking about, and really shows and explain how you can create and keep things in order. So don't take this chapter lightly. This is very, very important. It's going to help you so much in your process of creating new lenses and applications. Wonder what does it mean to optimize lens performance in spectacles? We have a whole section here into this and telling you what to do and how to do. Let's just go through some of the major points. Of course, rendering optimization. Reduce draw calls and materials, use instances for drawing the same mesh multiple times, and split texture into atlases to use one material with different UVs for texturing meshes. So meaning don't create 1,000 materials, just using instancing. This is the same as Unity. Avoid expensive material and lighting, so avoid PBR materials, reduce lights, avoid special graphic effects like reflection, shadows, and environment maps. So if your way around it. This is a scale for the textures. Disable invisible or unused mesh. I would say this is probably one of the things that you might not realize when you're just building a project, like stuff is on and you just turn on the lens. And once again, this might sound very basic, but I got a lens that I was testing, and there was a whole architecture project on every wall, and it was basically impossible to see. And in something that takes, that's the object pooling we talked about before. You really need to think about from the point of view of the user, of the experience, and just keep rendering things that you need. If you do this correctly, you might also maybe not even need to do this. That's it from my experience. We have a monitor panel. So there is actually a spectacle monitor. You can get FPS, and you can get a lot of more data out of this. There is also something called Perf, which is a way to monitorize your. Here there is all of a series of information that allow you to set it up. So if you are a fan of all of these stats for your performance of your device, this is where you need to look into. Finally, the debugging. So one thing that beside all of this documentation that you see here is looking into, because if you're developing for spectacles, you probably want to look into the way back also for spectacles. And in this case, we take advantage of this SIK log level provider, which is part of SIK. Why this is cool? There is a way to have a sort of layers or level for bugging things. You have 3 for error, 4 for warning, 6 for info, 7 for debug, and 8 for verbose. So this is very nice, and this is free with the SIK packages. So as long as you install it, you will be able to take advantage of the SIK log level provider. And we have also a lot of examples about this. This tutorial was mostly an intro into how TypeScript apply all of the vanilla TypeScript pattern to Lens Studio. I hope this was really helpful for you. Stick around because we're going to have a part 3, and finally we will open Lens Studio and take a look at a project, multiple sample repository. Consider if you're finding this information helpful, and I'll see you the next time. Peace.